Welcome to the Precast Podcast, episode 48. Today we are with the founders of Outside the Box Materials. Welcome, Jack and Mike. Thank you very much for joining us today. We really appreciate it.
Thank you. Look forward to talking to you.
Great. So, gentlemen, if we could, Jack, could I ask you to start with an introduction?
Sure. My name is Jack Aspenson. Mike and I are the founders of OTBM Materials. I've been a lifelong person interested in fixing problems. Mike and I got together about 3 years ago and determined that we saw a way to address the carbon issue in the concrete industry, or the cement industry to be more specific, and came up with solutions that we realized that could be easily marketable and easily comparable in price to what is being sold today to these guys. Mike?
Okay. Mike Riley. I am a material science background. I've been doing non-Portland based cementitious materials now for over 20 years. Have worked for several companies developing cement components, but also in the fiber industry. I've worked both sides. I've had a big emphasis on blast resistant products, ultra high strength materials. And again, Jack and I joined forces about 3 years ago and identified a couple products that have been kind of sitting out there, not really moving, and we examined why, and we were addressing how to move them forward.
Fantastic. Okay, could I ask how did you guys meet? How did you get connected originally?
I was an investor in one of his companies.
Okay, all right, fantastic. So my introduction to your business was last November at the NPCA annual convention. Yep. I attended that with Shea Concrete Products, and that was the first time that I learned about your business. Could we kind of jump in, maybe just kind of high level, like how was Outside the Box Materials, I guess, like originally, kind of founded?
Created?
Yeah.
Well, it like Mike said, Mike spent his life creating solutions to fix multiple problems. I too have a material science background, and there was a good synergy and a good communication between the two of us. And we through investigation, mostly Mike, I don't take any credit for this, he found some technologies that we believe that we could take to the next level. And once we were able to grab onto those technologies and really dig into what made them special, we put forth a small bit of cash and started moving it towards making it comparable by price. Because number one, you're not going to enter a new market without a comparable price. You're not going to come in 200% more and to be able to sell anything. But also we look at, I don't know if you're familiar with Blue Ocean Strategy, but Blue Ocean Strategy is a book that was written in the 90s that said, if you're going to create a company, you need to create a company that creates its market. You can't just create a cement market. You have to go in and find out what piece of it can you replace. And then we saw, we have seen, all of us that have grown up over the last 25 years, that there's a real high push to get rid of CO2 in everything we do. And through these products, we saw solutions that created almost a 100% reduction in CO2 over what was currently being utilized in the precast and ready mix markets.
So I definitely grabbed on to create a market. I guess one question I would have as you're working to create, as you are creating a new market with the products that you've developed, how has the introduction of your products been accepted by what I'll call the traditional cement market?
Yeah, that's the cement market. If you're talking about the producers of it, we're not getting a lot of feedback. The precast, the users of cement, the precast industry, the ready mix industry are really, really curious, interested, and want to be the first.
Yeah, it's
amazing. When we were at that MPCA conference down in Florida, and then at the precast show in Ohio,
yeah,
we were 3 to 5 deep the whole time we were there, and questions getting thrown at us from every direction. Tech cement was an immediate hit, and sulfcrete is a curiosity, but then they say they know that the industry is moving that way and they need to be a part of it.
How as these products are being developed, and as you continue to develop them and bring them to market, was the precast concrete industry, was that the first place you looked, or how did the process occur to get to the precast concrete industry?
Precast is in a need. If you look at the ready mix market and the precast market, when it comes down to Portland, over the last couple of years through COVID and also supply chain crunches, Portland's been on allocation kind of randomly throughout North America. The only way these guys in the precast world make any money is by making objects. So we immediately saw a need because our material, both products, is completely US based or North America based in some cases. And it's easy and fast to make. So we can keep up with demand by mimicking a ready mix or a Portland cement manufacturing structure.
What would make the most sense as we start to maybe dive into details? I definitely want to discuss, both products, but I guess I'm very interested to learn more about your ability to manufacture and have all materials needed right here in North America. Do we want to maybe talk kind of high level? You want to start with sulfcrete?
We could start. Let's start with tech cement because it's something that's ready now.
Great.
And it's something that we've already received orders on. And then sulfcrete is a little bit of an evolution, creating different creating different processes and equipment to do the same thing that they're currently doing. And so I'd let Mike address these questions, and he can expand wherever needed.
Okay, let's dive into tech cement.
So tech cement is in the family of geopolymer materials, which is not new to the industry, but it has never really taken root in what I would call large mass production opportunities. I've been involved in the geopolymer materials, which for anybody who isn't familiar with them are mineral-based materials that have similar chemistries to Portland cement, but are either derived from industrial wastes, albeit coal fly ash, slag from the steel industry, but also minerals that are just naturally taken out of the ground. There are clays that function in this market, other things. So I have been involved in these materials for now over 25 years. I found that we could produce, one of the things that industry got caught up in was really rapid set, really rapid repair. The thing is, a lot of the industry still just wants a good old 4,000 PSI concrete that it can use every day, as opposed to ultra fast 10,000, things like that. So essentially what I would say is I took technologies that I've been involved with and dumbed them down so that they can be used as an everyday product that still will allow you to, in the precast world, address some of the things that matter in terms of economics. And one is the ability to remove your product from a mold quickly. So we have the ability in cases with products we've been doing here for, in 2 hours, we can strip a mold. And yet at the same time, we're still not going to be more than a 5,000 PSI material. There are several different waste material products that we can use in these end product cements. They are around the US. They are, like in the case of fly ash, as you know, every coal plant has fly ash. The Portland cement industry uses it and loves it, but it is a very specific type of fly ash that it can utilize. It has to have a certain LOI, only so much carbon. There are sulfur issues in them and everything like that. Our products get around that. And so we can source raw materials that currently only have one home, and that's a landfill. So that kind of opens up the ability to expand the access to geopolymer cements. And that's one of the things I've really focused on over the past couple of years.
I think a standard mix that a lot of precasters might utilize would be, like a class 3 cement with maybe, a type 3 cement with maybe a class F fly ash. Right. Can you bring us through how, I don't know, I guess, can you dive deeper into the raw materials that go into tech cement?
Sure.
And, I mean, is it a combination of, it's both a hydraulic and a pozzolanic material combined?
I've spent a lot of time in the fly ash industry, internationally and in the US, looking at Class F fly ash and trying to make ash that was bad useful to the industry. So typically, most standards will allow you to put 20% fly ash in a Portland-based material. It's kind of the typical thing. By addressing some of the some changes in the boiler levels at the plants, we got up to an 80% replacement level of fly ash into Portland. And we're still able to meet all of the other strength requirements and other mechanical properties needed. So I just took that to the next level, and I like to utilize both Class F and Class C ash. Class C ash has a higher calcium content, so when you look at it chemically, it more represents a Portland structure. So those kind of things put together with one of the other things in the industry is a lot of the reactive chemistries that will fuse ashes together are extremely alkali. You have the silicate industry is, first of all, they're expensive. And second of all, you're looking at 14 pH, much like you are when you're working with Portland. So we have come up with, and I'll have to use the word proprietary here, chemistries that can react with these ashes in such a way that they never go up to that pH level. You can get the same strength level out of them and stay in the 9-10 pH range, which does several things. Originally, Jack and I developed these products started in the flooring industry as a self-leveling material. That's kind of where the genesis of this was. And then when we looked at it, it's like, okay, it can grow, it can modify. If by adding aggregates to it and building blocks, we can turn this into a much larger market. And then also you said, do I use other things? Yes, slag is a great additive. Once again, it's a high temperature fused calcium rich powder that is pretty standardized across the industry. It's available across the country by every major cement manufacturer. But again, it's almost always blended with Portland. Every of one of these SCMs out there, I just take the S out of that. I don't use them as a supplementary material. So I don't know if that is enough of an answer for you. I'm not going to get into the details of the chemistry here, but let me know what, if you want to drill down, just tell me where to focus.
Yeah. Well, so, maybe one thing, could we talk about the ability to utilize less water in a standard mix when you use tech cement? Could we maybe talk more about that?
Absolutely. The fly ash based materials are extremely wettable, I should say. So I have gone down in water cement ratios. You're typically at a 40% water cement ratio with Portland. We're in the anywhere from 12 to 18% water in tech cement materials, and still can get the same slumps that you would have to the point of having a self-consolidating cementitious material at those water cement ratios. That naturally now gets you to an earlier strength rise. And also without all of that water, you don't have as much issues with shrinkage and other concerns that are very typical. Also, these products work well with the standard admixtures that the industry is used to. Superplasticizers, air entrainment, de-air. I come from the school of the concrete world wants air because it's required for outdoor materials. But if you have a dense enough matrix, and I like to focus in the other direction, I like to get the air out of the material and make as dense a matrix as possible to resist scaling and salt attack and things like that. So two different directions. And that's something where you talk about industry compliance. This is where we have professional engineer, civil engineer PhDs working with us to gain acceptance by the industry, because occasionally we will say, no, we don't follow that ASTM standard, and this is why. But if we deliver the properties that they want, then they're okay with it. As long as we can prove it will pass a 666 test or any other test like that, for freeze thaw and things like that, then we're okay. But we have to prove that, and that's what we've been doing.
Okay, so from an industry acceptability standpoint, like a DOT compliance standpoint, as an example, are there national specifications in place or different things that you're currently working on to gain, national specifications, or just to simply kind of gain trust of folks that might be the ones that will approve or not approve these products for use?
Yeah, Mike, if you want me to address that. We are working with state and state and federal DOTs right now to, as Mike said, get acceptance for our products and allow us to skip past some of these requirements that they have for traditional Portland cement. And on top of that, we're also in the precast world, we're focused far more on areas where we're not going to need that for immediate revenue, and then backing into that with in the future, because it's not a fast process.
Yes. Yep. No, I agree with that. Might one of those industries be the architectural space?
Absolutely. That is a perfect example. Marine, anything on the coastal water system. Number two, anything that is going to be used in sound barrier or something that is not immediately impacting the human environment. Those are all things that we focus on, and those are large markets, and they're a great one to and those, the precasters that we met that do these projects, they're all in. They're ready to go.
Kind of going back to the Mike, you quickly talked about, whether it's a conventional concrete mix, which you do a slump test on, or, if we're using different admixtures, we are, doing a spread test for SCC. Are we doing all the same testing requirements as if it was a conventional mix or a mix that utilizes cement tech? Is it all the same in terms of
cement,
how you test it?
Yes, Tech Cement uses the standard testing for flexural, compressive, splitting tensile, but again, also freeze thaw, any sort of chemical resistance test, salt de-icing tests, all of that is the same. And I wanted to add one thing I didn't mention is, while we can try to make this in the market of the 4,000, 5,000 standard mixes, the formulas we have go up to 25,000 PSI. So I come from the UHPC background, so we can tailor the mix to adjust and to address those formulas, and even at that level, still be a self-consolidating material with about a 24-inch spread. So to be able to get that kind of flowability and that kind of strength is very different. And I'm familiar with the UHPC market, and it has its own, let's say, elevated economics. Is that a nice way of putting it? It's expensive. So, and we are, I would say, on the low end of that spectrum based on the designs that we've come up with from a cost standpoint.
Okay. Right, Hugh, one of the important parts in that is if in order for us to enter a market and start to absorb market share, you're not going to go in even keel. From a price standpoint. You need to come in a comparable price, so preferably less if you ask most of the precasters, but also offer them benefits beyond. Yeah. And that's how we structured the product.
Okay.
Well, I just wanted to add one thing here, if I could, Hugh. Fly ashes are not all created equal. Coals are different geologically, boilers are different. And so a lot of companies who try to work with fly ash, they have to have it tested. And does this one work? Does that one work? So what I've done is actually gone in and worked with the coal-fired boiler community to turn their boiler into a kiln, and to have them, instead of just burning coal, put in additives that we will supply that come out blended together with the fly ash to kind of supercharge it. And that's a patented process, and it's a unique process. But so that has been in test now for several years. It's something I brought into the company, and it's just a different way of looking at a coal-fired boiler and utilizing everything you can in it, including bottom ash and fly ash.
Okay, great. We talked quickly about water reduction. How about the ability to decrease CO2?
Okay. So in this product, since we are not utilizing Portland, I'm sure you're familiar, 1 ton of Portland equals about 0.9 tons of CO2. Mm-hmm. So if I'm generating all of my cementitious components from secondary materials that have already they're essentially a waste coming from another process, then you don't count that CO2 score for these materials. So in general, we're at about 65% reduced CO2 from the cementitious phase of tech cement. And I'm just noticing we haven't spoken at all yet about the sulfur concrete. I could segue into that and say for that same approach, the sulfur concrete is essentially a 99% reduction in CO2 over Portland cement. And
Okay.
if you want, we can go into that. So I don't know when you want to segue over, but
Yeah, no. Let's stick with tech cement for a little
Sure.
bit longer. Less water, decreased CO2, works with conventional admixtures, higher than typically needed, or equal strengths, can strip it faster. Very high density, microscopic density concrete, low permeability, high resistance to
Yes.
acids, very competitive economically versus conventional Portland cement products. With all that being said, how has the process been of getting acceptance and starting to get the product utilized commercially? Getting it into precast concrete manufacturing plants. How's that process going?
So the process is initially slow because you have to. Let me take a precaster as an example. Mm-hmm. You have to go in and prove to this is new. There's no Portland. Is it going to mix the same?
Yeah.
Is it going to flow the same? They have to see it. You can tell them that it's there, but you have to show them. So we create sample batches and we go in and we run a batch with them at no charge to them. I mean, we don't charge for our product.
Yeah.
And we actually do a sample run for them. Once they've seen that and see that, and we do a time and motion. So we pour an object, let's say a landscape boulder, and that boulder then we break the mold early. So we show them the whole process of where there's time savings and labor savings. I mean, one of the big challenges is when you do change time and speed up a process, does it change your labor structure, right? So you have to figure out the labor structure side of that, because you may be able to pour 20 molds much faster than break them and do 20 more. I'm just using 20 as an example number. And you may be able to produce 40 in a day where you're only producing 20 in a day, but you only need 4 people to do that instead of 5. So if you're not looking at the process end to end, number one, be less expensive than Portland. Number two, show them the benefits and the labor side of it. It increases their profitability. It increases their ability to turn product, which is the key to all business. How fast can I get something made and out? So that usually takes 1 or 2 times of working with them, because some have unique specifications, as I'm sure you're aware, and we have to be able to work with them on those unique specifications. Beyond that, then it becomes a simple, how do you want to order this? And the interesting thing is we can be configurable on that too, where we can allow them to order primary ingredients in bulk, and we make what I call black box of the fine ingredients to ship to them, which lowers their shipping costs per ton. So all sorts of benefits, depends on how they want to do it. We can be configurable.
We talked earlier, you indicated that all materials are local, North American based.
Correct.
What is the current process in terms of your manufacturing capabilities and getting the product out to customers?
The process itself is a standard blending process, powder blending process. Then we can take it in either supersat, tanker, or rail car. Pretty straightforward.
Yeah.
What we're trying to do, in the Portland industry, they're spread out geographically so that they can address the concentration of customers. We're doing the same thing. We're just changing the way it's actually made, and we're changing the way it's actually distributed by having it even faster and more locally produced, trying to keep it down to like a precaster. He doesn't like to ship products more than a couple 100 miles, right? The cost gets expensive. So how do we keep that cost down? And this is replicatable very easily. But you also want to stick close to raw materials, so you're not shipping them 1,000 miles.
Mm-hmm. So let's say, if a precast concrete manufacturer in Massachusetts was interested in utilizing this product, how would the process work of getting it to their plant? So
that right now, the main product, the main markets that we're focused on are Pennsylvania, New Jersey, New York area. That's where we have the highest concentration of current opportunities. Yeah. Michigan, Ohio, Kentucky area, Indiana, and then Georgia, Florida, Alabama area. If somebody wanted it in Massachusetts, we would look at, all right, where do we put a plant? Where do we work with a toll blender? Where are the raw materials available? Because a lot of fly ash is not available in that area.
Mm-hmm.
Where is something else available that we can pull in and reduce the cost for that group? And then we look at a density of potential customers beyond that company. Economics have to work for everybody, not just us.
Yeah. Okay. It sounds like, if there were folks that were interested in learning more about this technology and maybe wanted to talk to their precasters, is that available at this time?
Absolutely. Yeah, they can email sales@otbmaterials.com, and we'll get back to you right away.
Fantastic. Okay. How about, do we want to switch gears and talk about Sulfcrete?
Let's do it.
Okay. I have the one pagers in front of me as we're going through this conversation. I guess the one thing that really strikes me with Sulfcrete, well, I guess there's, kind of back to water and back to CO2 reduction, but I'm sure there's more than just that from a standpoint of technical information we could talk about.
So Sulfcrete is essentially, as you would think, it is a sulfur that is derived from the oil industry as a waste that is turned into a polymer. And there are many techniques that have been done over the years. Modified sulfur is probably 50 or more years old, originally used in Vietnam. Well, not originally, but was used in Vietnam as helicopter pads, but they were not durable. Bureau of Mines developed a version of it, and it has evolved over time. But in every case, it was using expensive chemical modifiers. It was a batch process. So to take this to the precast industry, all of a sudden, they would need a hazardous material with their plant, sulfur. They would need to turn it into a polymer there and make it all happen. We've done two things. We've selected much less expensive modifiers to turn the sulfur into a polymer. And we figured out a two-step process where we convert the sulfur into a non-hazardous material in one location, and then we're able to essentially call that our cement. And then we ship that to precasters wherever they may be. So we would have a regional hub that manufactures the cement. And then at a precaster, it is reprocessed with sand and stone and cast. Now, a couple key things here. It uses no water. That's the first and foremost, because you have to think about this. I like to call it an asphalt on steroids, because you melt it. You literally melt this and cast it by blending it with sand and stone in a shear mixer like one would do asphalt. The difference is when you cast it as soon as it reaches its quench temperature, you're close to 2000 PSI. Within 24 hours, you're done your reaction, and you can be as high as 10,000 PSI. But unlike Portland, there's no cure cycle. It does not have a 28-day aging curve. It's literally done at 24 hours. And at that point, it is virtually waterproof, vapor-proof, can incorporate. Yep, I'm sorry, acid resistant. Yes, completely acid proof. And the other key thing is it can incorporate as its aggregates a wide range of secondary materials, so that we have versions of it that are 100% recycled without using any virgin aggregate. And the other piece of this that we're heavily investigating right now is those other materials can be products that sequester CO2. So not only do we have a cementitious that eliminates the generation of CO2 from the cement side, but our aggregate side can also store CO2 in the same product.
Okay. So if you think about it, we are 99% less CO2 in our manufacturing, and we can sequester up to 40% more CO2. Right now, that's where we're at. There's not a product on the market that can claim that type of number. You have two different carbon credits you're generating off of a single ton.
While using no water in the mix.
While using no water. I heard a statistic, it might be interesting to your listeners. The Portland cement industry uses enough potable water to give 141 million people water for a year.
That's significant. So
it's a few countries.
That's a few countries. Yeah. Yeah. So this, what product is getting more excitement as you continue to talk to people, market, develop? Tech
cement has been the front runner right now because it's not a change in process. They're all very curious. As I said earlier, they're all really want to be part of Sulfcrete because they know the federal government and world governments are going that direction. The other side of Sulfcrete is, Mike, when he was talking about anything can be almost an aggregate in it. We're working currently with a couple projects to put hazardous materials into our products like mercury, arsenic, PFAS, and completely entomb them so that they don't leach out into the world. But the best benefit out of that is we can take those bad stuff, add it as aggregate to the good stuff, and turn it into a usable object, like a Jersey barrier, like a roadway sound barrier. So we're not just making it into a cube and putting it in a cave. We're actually turning it into something useful. That part of the Sulfcrete is the future. Tech cement is now.
That's interesting. How is Sulfcrete currently being manufactured, produced?
Jack, why don't you answer that one?
Yeah. Well, we have one facility right now that we're utilizing that uses a proprietary method that we've developed with a German company, but we've also found that there's other ways to make this. And right now, because the main issue with Sulfcrete, and I'll be candid with your listeners, is that we have to have the piece of equipment to deliver it to a mold. It's not worth anything. I can make all the Sulfcrete in the world, but if I can't deliver it to the mold, I'm pretty much dead in the water. So our last year has been in developing that equipment and keeping the costs low. You can't expect somebody to come in and say, okay, I want you to use this product, but it's going to be a $2 million machine. We want to keep that machine under a couple $100,000 and utilize equipment that they already have in place to transport the material from the raw materials from A to B. So again, going back when you're trying to fix a problem, you can't, part of it, rule number one is don't introduce new tools. Well, we have to in this case, but make that tool less expensive. Make the product comparable in price, and then make the final product and the turn on their labor, the increase in labor efficiency and labor dollar usage has to be done in order to be competitive.
And if I may add, the key here is while we talk about new equipment, in many cases, we're just slightly changing existing equipment that's used in the asphalt industry. So it's not like this is a foreign material that people don't know how to handle. It's a hybrid between concrete and asphalt. And so we're actually looking at the right company is somebody who's going to be able to cross train and bring people over from the asphalt industry to convert this process into a castable. And that's what we're in the process of doing. As you know, engineers are conservative. So a product like this takes some time to gain acceptance and people like to sleep at night. I get all of that. I've been in the industry for a long time. So it does take some innovators, but here's an example. One of the precasters we're working with said before this year is over, that he's going to be competing for a major project, and it's just say it's in the state of New York. And he said there are going to be 5 bids out there for that job. And he said the low bidder isn't going to get the job. It's the guy who's got the highest carbon reduction who's going to get the job. And he said if people don't wake up to that reality and start making changes in their own precast approach to this, they're going to be left out.
Okay. So you can imagine, see the business structure with Tech Cement and Sulfcrete. We work with them on Tech Cement, which brings down their carbon usage. We improve their processes of turn and labor and all that. And then slide them into Sulfcrete, changes their processes slightly, but it continues to build upon the reduction in labor, the turn on molds, and it also opens up opportunities for larger projects that are requiring this. There could be even a blend of those two products utilized in a certain project.
Do you guys have any competition in this space, or is this so far out front of what other people are doing or thinking that it's just you're way out in front of any other folks that are even thinking about it?
Which product?
Well, I would say
in the sulfur, no. We have one competitor that does do. What are they making, Mike? Rail ties?
They're making sleeper ties in Europe.
Yeah, okay. And they're using a very expensive modifier, so they don't have our technology. So if you want to say we consider them a competitor, there's a competitor in Canada, again, both using the same modifier, and not creating. They don't have the continuous mix process for manufacturing, the Portland replacement. So if you want to look at that as, yes, we're way ahead of them because we've got intellectual property on this. And we can also, through Mike's patent with the fly ash, we can control our quality level. We're ahead of the game by quite a ways.
Okay. And then, from a tech cement standpoint,
it's interesting. One of the precasters, you guys are an inquisitive group. you really like to go out and find out what's what, which we appreciate 100% because we're very upfront. Obviously, we don't give away formulations, but we tell you how we're going to do something and how we're going to work with you. And also, we're a partner. We look at it as a partnership. But one of the precasters has gone out and seriously gone through the entire Google search database. I think he's found 5 companies that say they're geopolymer, and his response to us was, "Well, they all have kind of what you're doing, but no one knows how to take it to market. You guys are already taking it to market." He said, "So you're already years ahead of them." Yeah. Most of them are academia. We got a cool formula. You want to buy it?
Yeah. Has the Portland cement has PCI shown interest?
We have had a couple kind of check in around the boundaries. Is that a nice way to put that?
Typically, it's the admixture companies who have shown interest for 2 reasons.
And the fiberglass rebar has really shown interest.
Right. But for one reason, they want to understand if this is going to grow, are there specialty admixtures they need to be developing to help out? Or are they compatible? And at that point, I've worked with several of them in the past, and their interest has always been compatibility to keep selling what they're good at. So yeah, they're always ahead of the game because they want to be able to sell you that chemical that will make it tick. Understood. It's good to keep them as friends.
Understood. How about, I'm not sure if I'm asking the question the right way or not, but let's say if you guys were going to give your best estimate in 10 years from today, do you think there will be, I guess, like how much of a decrease in standard Portland cement will there be just based on driving technology and the ability to utilize other products versus what we're used to with class 3 or type 3 cement? What might you estimate just new technologies and continuing to drive what you guys are doing right now will do to kind of disrupt that market?
Well, let's take the precast market because ready mix is going to be a little bit tougher challenge. Like I said, they're going to be, and I'm taking a precaster partner of ours, his language. He said they're going to be an evolution. They're not going to be a revolution. So I see that a lot slower. But in the precast industry, in the next 10 years, I'd say 20 to 30% will be replaced by alternate Portlands or alternate cements. Okay. Easily 20 to 30%.
Yeah.
And there are many people out there developing alternate methods as we speak, and they're all trying to do the same thing. They're all looking at the CO2 reduction as a means of getting out there. But the Portland cement industry has infrastructure, and that's the key. They are everywhere, and that's going to be and the good news is the Portland cement industry is also trying to change their own products and stay in the game. Right. They recognize this, and they're not resisting. They're in many cases, I'd say, taking a good leadership position to try to reduce things and be a part of this moving forward. They don't want to lose their business. So, so everybody pulling together. We're not here to take over the market. We want to do as much growth as we can, but recognizing that there are other good ideas out there, and hope everybody's successful.
What might your biggest challenges be in the next, 6 to 12 months, maybe 24 months, to really continue to drive tech cement and get that out into the marketplace more heavily?
That's a good question. On the tech cement side, the challenge is literally bringing on a density of precasters within a certain manufacturing area. On the sulfurete side, finalizing the equipment, really that's it. We already have command of our supply through a partner. We already have command of our manufacturing. We already have toll blenders and stuff, and then we're building our own plants. So really, it all comes down to getting the buy-in of the precaster, getting them trained and comfortable with the product, and having something local that makes it economically beneficial.
Yeah,
everybody's got to win, or nobody wins.
We say here at Shea Concrete Products, teamwork makes the dream work.
Yep.
And that's a big, it is so true. And it can be so hard to kind of get, based on different organizations. I mean, once we are really doing well when everyone is, the end goal is winning as a team. Things really start to happen when we can all be on the same page. Yeah.
We don't call them customers, we call them partners.
Partners. Yeah. That's fantastic.
Because we are a partner, because if you think we're stopping at these two formulations, I mean, in tech cement alone, Mike, what do you have, 5 now?
Right now, and there are customers who will come to us for something specific, and if the market's there, we can adjust, we can tailor.
Very good.
And that's gonna happen as you partner with people, right? And there's going to be projects that require certain specs. We can work with them.
It sounds like right now you actively have people seeking you out to help them meet the requirements or to meet specifications of, I guess, more in environmentally focused aspects of a project. Is that fair to say?
That is very fair to say. That's a matter of fact, at the NPCA show in Columbus, I'd say out of our groups that we talked to, probably 60% had projects.
Yeah, it's funny. As we've been talking about this, I've been thinking about, we make a certain retaining wall product line that gets used, we're, in the Northeast, so it gets used on shorelines often. And the ability to manufacture and generate a product that can almost be inert to seawater, that's a really interesting thing.
Well, good for you. Both products are inert.
Very interesting part of the.
By the way, one of the consultants that we work with a lot, who's actually is I don't know, is he high school or grade school friend? Our marine engineer.
Since the second grade, yes. He's a professional engineer. He's a PhD professional engineer and has 40 years in experience in the field. And he thinks the seawall opportunity is one of our biggest opportunities immediately. So
Great.
But what we have to look at is, do we want sea life to stick to it? Do we not want sea life to stick to it? Mm-hmm. And so we can actually tailor the products to accept or reject.
Yep. Okay. I mean, I could see when I came out of college, I had a very interesting job. I worked for a marine engineering company, and I was young and traveling, and I got to learn how to be a diver and travel to really neat places with the U.S. Coast Guard and U.S. Navy and go underwater and inspect, bulkheads and piers and wharfs. And it was a really interesting project, but it was always interesting to inspect the concrete structures and to see how some stood up and some did not stand up. So I guess, I would assume that the federal government, specifically, Navy, Coast Guard, Marine installations would be really excited about this, as well as many other industries.
Well, Hugh, if you want to dig in deeper, we can always have another call.
There you go. Yeah, no, this has been great. Yeah, no, I mean, I'm excited to just kind of stay in contact at the shows and see how you guys do. But definitely maybe a follow-up podcast episode.
Sure.
We're approaching kind of getting up to a length of podcast where we find folks don't always stay committed to it. So as we start to wrap things up, I want to, thank you, Jack. Thank you, Mike, for your time. And as I say, in the future, maybe we'll schedule a follow-up. And I'll be honest, we run technical engineering seminars out of our headquarters in Amesbury, Massachusetts. And I think this might be I might touch base with you to see if I could ask you guys to provide a presentation. I think the attendees would love it. I think this would be a really interesting presentation. So,
I mean, that spec drives a lot of jobs.
Excellent. Okay. Well, gentlemen, thank you again. As I say, we're excited to get this episode out. I will make sure that folks that listen that might have additional questions or comments can easily find your email addresses. We'll have that easily available as part of the webpage for this episode. But I want to thank you again. You guys have a great rest of your day. Thank our listeners. And we'll get this live as soon as we can. So,
all right.
All right.
Thanks a lot.
Hugh.
Thank you again.
Just
Take care.
remember, if they're interested in talking to us, sales@otbmaterials.com. And if they need information at otbmaterials.com.
Okay, fantastic.
We can get back with them right away.
Excellent. All right. Thank you very much.
Thank you.
Take care.